Hello, this is your Chapter 10 test. I'm Mr. Brooks. Here we go. Let's figure out, let's see here, here's our pointer. I think we'll use this pointer today. Okay, these first three, it says simplify the radicals, all right? It says, for example, you'd want it to look like 5 radical 3 or whatever. If you want to do that, you can, or I know you do have the option. We've told you from the very get-go. If you just simply want to simplify these using your calculator, that's fine. Just make sure you round it off. So if it's, say, 7.45620, round it to 2 places after the decimal. So we would say 7.46 to round that up. Okay? That's all you got to do for the first 3. On number 4 and number 5. Okay, you're to use the Pythagorean theorem. Mr. Heppner has got this already written for you on your paper, but just so you remember, a squared plus b squared equals c squared. And again, make sure you label your sides. This is a, this is b, or vice versa. It doesn't really matter. And just remember that c is always opposite the 90-degree angle. Plug them in, all right, and make sure you're very careful, especially when you plug in a radical. For example, if it's a squared, we're going to say radical 5, and you want to make sure we square the whole thing like that. Make sure you close your parentheses. All right, that's number 4 and 5. Taking a look now at 6 and 7. Similar concept. We're going to use Pythagorean theorem. He's got it written for you here once again. Okay. These are 45, 45, 90 triangles because there's the same. All right, we want to find x, which in this case, if you take a look, he's directly across the 90-degree angle. So what side would this be, A, B, or C? I hope you're thinking C. So you solve and find the length of that side. In number 7, slightly different. Actually, really no different at all. There's your C. He's across the 90 degrees. But what do we think he might be? Well, again, if you look at these tick marks, or the arcs, I'm sorry, those means the opposite sides. If they're the same, their opposite sides are the same, so that means he's really 9. So, again, you've got your side A, your side B, figure out what C is. On number 8 and 9, you need to determine, do we have enough information to prove that the triangle is a 45, 45, 90? So is there enough information given here to say that, yep, it's a 45, 45, 90? You just write yes or no on number 8 and 9. Okay, guys, we want to find the hypotenuse. Now, this is the 30, 60, 90 triangle rule, and a little bit of this got cut off, so just let me fill this in. That's 30, 60, 90. This is hypotenuse. This was long. This was short, and this was short. The words there just got cut off a little bit. But Mr. Heppner's got these here to help clue you in that the hypotenuse is the short leg times 2. The long leg equals radical 3 times the short leg. Your short leg equals the hypotenuse divided by 2, or the short leg is the long leg divided by radical 3. You got 2 ways to find your short leg here. Okay? Now, you just got to figure out who's the short legs and who's the long legs. Well, remember, the biggest angle is always going to have the biggest side opposite. So the biggest angle out of a 30, 60, 90 is going to be the 90, right? So there's your biggest side, so that would be C, you could call him. And then your next biggest is going to be opposite to 60. That would be B, and then your shortest would be opposite to 30, so that'd be your A. So they give you A, you need to figure out B and C. Well, actually, in this one, they just want the hypotenuse. Okay, so that is for number 10 and number 11. Okay, and you probably are going to want to use that information, too, to also help you with 12 and 13. They want you to find the length of the leg. So again, here's a leg. He's opposite to 30, so he's probably one of the short legs. Okay, so use one of these up here. This one would be the B in number 13. He's the middle-sized one. So again, you're going to use one of these to figure out what the length of this guy here is. Okay, 17 and 18, they want you to find the tangent of A and B, put it in a fraction simplest form. Now, Mr. Hepner wrote here, remember, tangent is opposite over adjacent. So let's see here. If I'm going to be thinking tangent of A, if I look opposite, it'd be there, and the adjacent would be here. If I'm doing B, okay, if this is where I'm working out of, over here is now my opposite, and this is my adjacent. So use both of those, set it up as a fraction, and keep it in a fraction and simplify. And that's what you're doing on 17 and 18. On 19, 20, and 21, you just plug that in your calculator. Find sine of 27 degrees, cosine of 45, sine of 45. 4 decimal places. So you're going to have maybe a whole number, or let's say it's 2 point, and then you got to have at least 4 decimal places. Okay? So your answer is going to look something like that. Now, on 22 and 23, very similar to the tangent problems that you just did, only you need to find the sine of A and the cosine of A. So all you need to do is, that means angle A is our reference point. So that means we go over, this would be the opposite, this is the adjacent, obviously that's the hypotenuse. So you're just going to set it up now this using one with sine and one with cosine. Okay? So just to kind of give you an idea, if I was going to find sine of A equals my opposite, which is 6, over my hypotenuse, which is 12. And reduce that to find that. And if I was going to do cosine of A, it's the adjacent over hypotenuse, so it's going to be 6 radical 3 over 12. And you want to simplify that down. That's how you do both of those. Okay, for 24, 25, and 26, you're going to use this picture right here, all right? And for each time you do this, I would relabel the triangle every time, okay? And Mr. Hepner's got everything you need here as a reference: Pythagorean theorem, sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. So, for example, in 24, they want you to find C. So that means the length of this right here, okay? So that's going to be Pythagorean theorem there, okay? So I'll put Pythagorean theorem there to help remind you that that's what you're going to want to use for 24. And 25, we want you to find the measure of angle A, okay? So you could use one of these, okay, sine, cosine, tangent, to figure it out. Really, you could pick either one you want because you're going to have all 3 sides of the triangle. Same way with angle B. Okay, so for 26, they want you to find that one, and you again could pick either one of those 3 to use. If you have questions, see Mr. Hepner. Okay, number 27 and 28, the directions just want you to find the measure, approximate the measure of A, angle A, to the nearest 10th degree. So they said the sine of A is 0.63, all right? And then cosine of A is 0.26. If you need a little help with that, make sure you ask. And then 29, 30, and 31, they're just like the ones we did before. We're going to use the figure, and you still want to use this information up here that Mr. Hepner has written down to help you figure out all the sides, okay? That's the end of the test, and I hope you have a great rest of the day. Bye-bye now.